Hello, pre-calculus students. This is Mr. McAllen, and we are on day 4 of our flipped classroom trial. And what we're going to do today is we're going to talk about, or I'm going to talk about, two objectives. The first objective is how to calculate trig values if we give you an angle. And I want to explain what that actually means. And then the second part of the video, the second set of problems will be um, how to find what angle values you have for the triangle if we give you a trig ratio. So these are like kind of opposites of each other. So the first part, um, what they have to do is they have to say, if you have a 30-degree angle, and let's just say they say find the trig ratio for a 30-degree angle, like find the sine ratio. So they're basically asking you, in so many words or less, if you make a right triangle and your angle, we've been labeling it so far as beta or alpha or theta, but let's say that they tell you that you have 30 degrees. And when you plug into the calculator the sine of 30, the calculator is going to give you back 0.5. So what you want to do is understand that the opposite side to the hypotenuse, because that's what the sine ratio deals with, is equal to what's equivalent to 1 over 2 or 0.5. So this side, the opposite side would be, you could say it's 0.5 and the hypotenuse is equal to 1. Or you could think of other ratios that are equal to 0.5. For example, 2 over 4 would work, where this side could be 2 and this side could be 4, and so on. So this is generally what we're trying to do when we ask you to figure out a trig ratio of a certain angle. I want to draw your attention to the graphing calculator. And if you see here, we have basically in this region right here, we have 3 trig buttons. And the buttons are sine, cosine, and tangent. And we have these inverse trig buttons, which we'll be using later. So I just want to point your attention in those directions. So what you can do is, in order to calculate a trig ratio, all you really need to do is just access the calculator, make sure you're in degrees. So you do that by checking out the mode button. So over here, I'm just going to write sine of 50 degrees, 33 minutes, 22 seconds. And when I go to the calculator and I check out the mode, notice I'm in radians, so I want to switch that to degrees. So that's something you should always do when you grab a graphing calculator. Switch to degrees, go back to the home screen, just clear out what's on there. And I'll say, let me find the sine, and you can enter it as 50 degrees, 33 minutes, 22 seconds. So we'll put in 50. I'll go to, like we did in class today, the degree symbol. And then 33, I'll go back to the angle symbol, and I'll choose minutes. And I'll do 22. I'll go to the alpha key and the second symbol. And when I, have to just change that back to out of the alpha mode, and I'll put this as a parenthesis. And when I hit enter, I'll get the trig ratio for that angle. Now that is an inexact ratio, it's approximated, so that says 0.772. So when you say the sine ratio of 50 degrees, 33 minutes, 22 seconds is equal to 0.772, what you're basically saying is, if this is that 50-degree angle, I'll just label the angle A. That's 50 degrees, 33 minutes, 22 seconds. That ratio says that the opposite side is 77.2% or 0.772, where the hypotenuse would be 1. And you can figure out what the other sides would be using Pythagorean theorem or using other trig ratios. Now we come to the next problem. If you notice, the calculator does not have a secant button. So what you have to do is remember that the secant of 50 degrees, 33 minutes, 22 seconds is equal to the reciprocal of cosine. So what we first do is calculate the cosine of 50 degrees, 33 minutes, and 22 seconds. And we would flip that fraction or do the reciprocal. So notice you do have a button for the cosine. If you find the cosine of that angle and then you do 1 divided by that value. So for example, the cosine of 50 degrees 33 minutes, 22 seconds. If I do that, I'll just get the calculator and I'll just go up and change the sine ratio. Just hit enter so I can go back and edit the ratio instead of using sine. I'll just press cosine. Well, the reason I'm using cosine is because that is the reciprocal function to secant. So cosine is equal to 0.6353. And then if I want the secant, remember in class when we worked on these problems using fractions, we just flip the fraction. Well, we do the same thing here where we just say it's 1 divided by 0.6353, and that will give us a secant ratio. So, and on your calculator, if you have this value already in memory, if you hit the x to the -1 button, that just turns the fraction upside down because that's the reciprocal button, and the secant would equal 1.574. So what I want you to try to do on your own, I want you to try to find the tangent of 30 with your calculator, and then tell me what the cotangent of 30 degrees would be. I'm going to pause the video now. And when you come back, I'll have the answer displayed so you can see if you match up. Okay, so if you tried to find the tangent with the calculator, since there is a button on the calculator, you just enter in tangent of 30 degrees, and that tells you that the ratio is 0.5773. And what that means is if the angle was 30 degrees here, that the opposite side, because remember tangent is opposite over adjacent, so the opposite side would be 0.5773 and the adjacent side would equal 1 to make that ratio work. For cotangent, remember it's 1 over, or the reciprocal of the tangent ratio, so you just have to do 1 over 0.5773. And on the calculator again, there's 0.5773. So if I just use the reciprocal button, I'll get the flipped fraction, which is 1.732. So the cotangent of 30 is equal to 1.732. Next example is the opposite case. They've given us a ratio of sides and they're asking for the angle. So when you do this, if we have the sine of beta is equal to 0.3532, what we use to get to beta is we use the inverse trig function, the appropriate inverse trig function. So if I do the inverse trig on the sine of beta, remember what we did with the logarithms and exponentials, the inverse always undoes the function. So you have to use the inverse on both sides. Whatever you take the inverse on the left, you have to do the inverse on the right. And as you can see here, that the inverse of sine would cancel with the inverse, with the sine function, leaving you with beta is equal to the inverse of 0.3532. And on your calculator, you would use the inverse button. Now, if I go back to the original area where we looked at the calculator, notice this is the inverse key. So you have to use that. That's the area of the calculator you have to access, the inverse sine button. So I'm going to go on my calculator and I'm going to hit the second function key, inverse, and that is 0.3532. And when I put that into the inverse button, it will come back and give me an angle value. So the angle beta is equal to 20.683 degrees. So moving along, we'll look at how to do the angle for theta for cosine. So again, if I have cosine, then on both sides, I'm going to use inverse cosine. And I'm going to just write cosine of theta here. And this was 424. So the inverse undoes the cosine, leaving you just with theta. And then, so the angle you want when you put the ratio inside, let's use a calculator again, the inverse cosine of 0.424. Hit enter. and that says it's 64.91 degrees. Now, this is probably the hardest question of all questions. We have to find the secant, we have to find the angle, and we don't have an inverse secant button. So what we first have to do when you're trying to find alpha, we have to change this to cosine, because secant is the reciprocal of cosine. Remember that cosine of alpha equals 1 over the secant of alpha, or the secant of alpha equals 1 over the cosine of alpha. So what we have to do with this problem is we have to rewrite it as cosine of alpha is equal to 1 divided by 1.253. That would be the reciprocal of that. We calculate that value. 1 divided by 1.253, and we get 0.7980. So cosine of alpha equals 0.7890. Now we need to solve that problem as if we did before. And remember what we did. To find the angle, we have to use inverse trig. So I'll inverse cosine both sides. I know this seems like a lot of work to just show this, the process of removing the cosines, but this is how the cosines wipe each other out. We're left with alpha, and on your calculator, you just type in the inverse cosine of 0.7890. So when we do that on the calculator, inverse, or second function key, to get the inverse cosine, we'll put in 0.7980, and when we hit enter, you'll have the angle. The angle alpha is equal to 37.06 degrees. Okay, so as a final question, I'd like you to try to answer these two on your own, and I want you to report them back through the Google form. Okay, I want you to tell me if cosecant of theta equals 2.0. We would like you to find what the angle is. And if the sine of beta is equal to root 3 over 2, we want you to find the angle for that as well. So these will be the two questions that you see, and you'll have to use your calculator and try to go through the methods that we talked about during this video. So hopefully this video helps, and I look forward to hearing your comments tomorrow.